Welcome to our deep dive into creatine beyond the gym. You already know it as the go-to supplement for building strength and power, but lately people are touting it as a cognitive enhancer and even as a tool for healthy aging. In this series, we're going to separate the evidence from the hype and find out what creatine really does for your brain and longevity. The buzz on social media makes it sound like creatine is some kind of magic pill for your brain. Is this actually a breakthrough or just another longevity trend? Before you jump on the bandwagon, let's take a hard look at what the science says and what remains speculation. Research on creatine has been going on for decades, and we can group the findings into clear tiers. There is rock-solid proof that it enhances strength, power, and lean mass. There's a growing but still moderate body of evidence that it helps with cognition and mental fatigue under stressful conditions. The idea that it protects the brain or slows age-related decline is still emerging, and claims that it will extend your lifespan outright are at this point purely speculative. Keeping those levels in mind helps temper our expectations. Creatine is a compound your body makes from amino acids, and you also get it from meat and fish. It is stored in cells as phosphocreatine, which is basically an energy battery that can donate a phosphate to adenosine diphosphate to quickly regenerate adenosine triphosphate. About 95% of your creatine lives in your muscles, ready to fuel explosive efforts. A much smaller fraction, around 5%, is in your brain, where it plays a role in maintaining energy supply for cognitive tasks. The magic of creatine is that it turns a low-energy molecule back into ATP in a matter of seconds. When your muscles or brain demand energy, phosphocreatine gives up its phosphate to recharge ATP, acting like a temporal buffer. It also shuttles high-energy phosphates from the mitochondria, where ATP is made, to the parts of the cell that need it the most. This quick turnover is why creatine is critical for short, intense bursts of activity. Muscle tissue relies on phosphocreatine to resynthesize ATP during sprints, lifts, and other short-duration efforts. Your brain, although it makes up only about 2% of your body mass, consumes roughly 20% of your total energy. When energy stores in the brain drop, you feel it as cognitive fatigue, slower reaction times, and reduced mental performance. Both tissues depend on rapid energy turnover, but the demands and consequences are different. Situations such as sleep deprivation, low oxygen environments, and prolonged mental work can drain your brain's ATP reserves. Supplementing with creatine may help buffer these deficits by increasing brain phosphocreatine, but the effects depend heavily on context. People under stress or with low baseline brain creatine might feel sharper, while those who are well rested and already have adequate stores may notice very little. Studies using high-loading doses on the order of about 20 grams per day have shown improvements in memory and reasoning in older adults, and those benefits often persist after the supplementation period. By contrast, low doses of 2 grams per day in healthy young adults typically don't produce noticeable cognitive changes. Outcomes vary across studies and age groups, and many trials don't even measure brain creatine levels, making it hard to draw sweeping conclusions. As we age, our brain's phosphocreatine levels tend to decline, and lower levels are linked to cognitive decline. Maintaining adequate energy availability could help protect neuronal function. Some researchers believe that personalized dosing based on someone's baseline brain creatine might be needed to see benefits. A one-size-fits-all approach may not work for everyone. Animal experiments suggest creatine can reduce oxidative stress and improve plasticity in areas like the hippocampus. Unfortunately, the translation to human neuroprotection has been underwhelming so far. Clinical trials have yet to show that creatine supplementation slows neurodegenerative diseases, although there are promising lines of inquiry in disorders like Parkinson's and Huntington's. Right now, it's an intriguing possibility, not a proven therapy. When you put all the evidence on a single scale, performance outcomes stand at the top with the strongest support. Cognitive effects occupy a middle ground with moderate backing, particularly when people are under stress or energy deficit. Neuroprotection sits lower with preliminary data, and the idea that creatine directly extends lifespan is at the bottom with the weakest evidence. This visual helps you prioritize where creatine truly shines. There's no doubt creatine helps you hang on to muscle mass and strength, which indirectly supports healthy aging by keeping you active and independent. But there is no evidence that creatine itself extends lifespan in humans. Longevity claims you see online are, for now, more marketing than science. Any real impact on lifespan will require a lot more research. If there's one area where creatine earns its reputation, it's here. Large meta-analyses show that supplementing can boost maximal strength by roughly 0.4 of a standard deviation compared to a placebo. It also enhances peak power and your ability to repeat sprints or lifts, and it supports lean mass gains when you pair it with resistance training. These results have been replicated again and again. For older adults, creatine paired with strength training is a powerful combination. It reliably improves upper body strength and functional capacity, helping older individuals maintain independence. Lower body benefits are a bit more variable and sometimes require higher doses or an initial loading phase. Nutrition professionals often recommend taking creatine along with adequate protein, staying hydrated, and engaging in regular strength training for the best results. So who stands to gain the most from creatine beyond just lifting more weight? People dealing with sleep deprivation or high cognitive stress might feel sharper with supplementation. Older adults experiencing declines in muscle and brain phosphocreatine could see improvements in both physical and mental tasks. Athletes, students, or professionals who need extra resilience for complex mental work may also find it beneficial. Context matters. Some will notice big improvements, others very little. For most people, a daily dose of about 3 to 5 grams of creatine monohydrate is sufficient. You can do an optional loading phase of around 0.3 grams per kilogram of body weight per day for 5 to 7 days if you want to saturate your stores quickly. But it isn't essential. Consistency is key. Take it every day to maintain muscle and brain phosphocreatine. And remember, creatine works best when paired with a balanced diet, adequate hydration, and strength training. It's important to be realistic about what creatine can and cannot do. The cognitive and potential longevity benefits are modest and heavily context dependent. Very few studies actually measure brain creatine levels before and after supplementation, so there's a lot we don't know about how much gets into the brain. There's also no evidence that creatine directly extends human lifespan or treats neurodegenerative diseases. These are exciting areas of research, but we're not there yet. Here's the bottom line. Creatine is unequivocally proven for building strength, power, and lean muscle, and it's one of the safest and most effective supplements you can take for physical performance. There is some evidence that it can support cognitive function, especially under stress or in older adults, but those effects require higher doses and aren't guaranteed. Neuroprotection and longevity remain speculative and need more study. So think of creatine as a foundational supplement with some promising extras, not a miracle cure.